All right, I'll stop at 35. 35. Oh, awesome. That's awesome. Y'all got derivatives down okay, right? You good to go? All right. But the real question is, if you're ever attacked by a group of clowns, what are you going to do? You're not going to take the derivative. What are you going to do? Go for the juggler. That's good advice. Also, don't go to jail. Really not a good idea to go to jail. Okay, we will see later in the semester some sine and cosine functions. We'll need to take their derivatives. Uh, just sort of tuck it away right now. You don't need to know right for a little while. But the derivative of sine is cosine. The derivative of cosine is negative sine. And here u, we're using u sort of to represent some function or some variable. Right. So those are derivatives of our trig functions, sine and cosine. So we're not going to need them for a while later in the semester. Also, later in the semester, we'll need the chain rule, which if you're in Calc 1, you've not seen the chain rule yet, but many of you have finished Calc 1. The chain rule looks like this. It says that dx dt is the same as, or is equal to, dx du. Goodness bless you. That is the derivative of the function x with respect to u times du dt. All right, so if you think about this, our du's could cancel, and we'd be left with the same function that we had. For example, let's say that I had this function, x equals 2 cosine t squared plus 3. So I have this function of x that's defined by t, or with respect to t, but I have this function that will vary with time embedded within this cosine function. So I kind of have this function within a function that makes it a little bit complicated to to uh, to solve the derivative. However, I can let u equal t squared plus 3. Right, so that I could rewrite this as x equals 2 cosine of u. And then we can solve this derivative, like I can solve what is dx du, and I can find what is du dt, and so then I can have dx dt. To show you how that would work, I would say dx dt will equal to dx du. Dx is going to be 2 cosine u, because this is x right here. I plug that in there. Here's my dx du, this whole thing, times du dt. That's going to be the derivative of t squared plus 3 with respect to t. Now both of these we can do. Both of these derivatives separately we can do. And so I take this derivative, and then I take this derivative, and then I'm done. I have the answer. So the derivative of cosine, gosh, what was the derivative of cosine? I always forget, is it plus or minus? It is minus. How do y'all remember that? Do you just know it? Okay, that's smart. Okay, so the derivative of cosine is negative. The 2 just comes out, it's a constant. Negative 2 sine of u. So that's the first part. And then the second part, the derivative of t squared plus 3 is 2t. And then I do a little bit of simplification. I get negative 4t sine. And then I plug back in my expression for u, which is t squared plus 3. That's the chain rule. Again, it's going to be a while till we need the chain rule. Gosh, a while, like towards the end of the semester. So you'll probably have seen the chain rule, but just as we're reviewing calculus, I want to give it to you now. But if you don't get it, don't sweat it. It's not that big of a deal. Okie dokie. Let's do a few clicker questions. We've already done this stuff. We have not done this. We're going back to dimensional analysis. if the displacement of an object x is related to velocity according to this relationship, x equals av, what are the dimensions of the constant a? Hold on, we'll do this one, then I'll change the colors. I know the colors aren't real great on this. But I have x equals av, x is position, v is velocity. What are the units of a? Go through our dimensional analysis. You need to figure out what are the units of a so that this side will have the same units as this side. All right, I will stop at 10 seconds. Stop at 120. 125, I'm sorry, 125. Okay, we're sort of all over the board here. Students often have trouble with this. It'll help you, though, with your algebra skills, and it'll just help you in the class overall to really get dimensional analysis. Let me show you. I have x equals av. I'm just going to put in my units. Well, there are a couple different ways you could do this. Let's do it this way. Let's solve this for a. A is equal to x over v, right? I divide both sides by v, and then x has units of meters, and v has units of meters per second. So that is going to be meters times seconds over meters. And so the right answer then is seconds, which is which one? Which is time, C. A crate has these dimensions, 1 by 1.2 by zero point 0.8. If there are 3.28 feet per meter, then what is the volume of the crate in cubic feet? You can use your calculator, but try just doing a quick little estimate because, you could just change this to 3, and you're going to find that one of the answers will become apparent. So use your calculator if you want, but try doing it without it too. So you need to find the volume and then convert that volume to cubic feet, feet cubed. Remember, you can ask your neighbor what they put. Although y'all are sort of all over the board on this. So. Guys, what is the volume in cubic meters of this thing? Roughly. What is it roughly? It's roughly 1, right? This times this times this. It's not exactly 1, but it's roughly 1 cubic meter. All right, so now I want to know how many cubic feet are in a cubic meter. Well, how many feet are in a meter, roughly? 3, all right? And so I want to convert my cubic feet into, or my cubic meters rather, into cubic feet. Remember what you're supposed to do when you have units that have exponents in them. Give you a few more seconds if you want to change your answer. Sorry, did I just like that? I'll stop at 210. Okay, again, sort of all over the board here, but the answer is A. Again, I can just say, you can do this if you want with all the correct values, but if I just say 1 times 1.2 times 0.8, That is approximately equal to 1. Does anybody know the exact value? 0.96. So that's 1 cubic meter. And then 1 cubic meter, if I want to convert it into cubic feet, I know that in 1 meter, there are approximately 3 feet. There are actually 3.28 feet, but I'm just going to try this now. What do I have to do to this conversion factor? I have to cube it. And so that's going to give me 27 cubic feet. But I made some estimations along the way, so if you do this correctly using 3.28 instead of 3 here, you'll get 34. Okie dokie. It's important you will see this, how to, on the test, either in multiple choice or in your free response, and all semester, how to convert units. So if you're having trouble with this, as many of you are right now, then please come see me. We'll have some more practice problems. Look in the homework. There's some extra practice for you there. Remember, I don't take up the homework, but it is a good place for you to practice for the exam. The solutions are online, but I recommend that you try working through it on your own. You should be able to work through most of it now. Chapter 1 is on the website. Maybe this weekend set aside an hour or two and try to work through some of those problems if you haven't already. Okay, a jet airplane climbs at 15 degrees with respect to the horizontal, follows a straight line path for a distance of 400 meters. That means that this plane, it starts here and it travels 400 meters at an angle of 15 degrees. How much altitude does the plane gain? How far is the plane from the ground after it travels a straight line path of 400 meters? And I'm going to post all these after we finish with chapter 1. I'll post all these PowerPoints on the website. There's a place there. This will also be in your workbook when you get it. Can I just say, y'all can keep working, but somebody left this note up here, and this is like the nicest thing ever. I've never gotten a note like this. This wasn't to me, it was to somebody else. Can I read it to you? I just found it here. Some student wrote it. It said, Dear Mrs. Kim, I love you, Mrs. Kim. You is the best teacher. Love forever. And then there's a heart, and it says Mrs. Kim, and I don't know, Ken Gel, I think his name is. I never get notes like this, people. Why is that? Why I never get notes like this? Alright, I'm done here. I'll give you about 15 more seconds, or 10 more seconds. I'll stop at 3:10. 3:10. Alright, so this is a trig problem. I have a right angle triangle here, a right triangle. I know this angle is 15 degrees. That's what it means when it says it's 15 degrees with respect to the horizontal. That is 15 degrees from that positive x-axis or from the horizontal. And I want to know what is the altitude. The altitude is this. I know I have the opposite side and I have a hypotenuse. So which trig function am I going to use? Sine. So I say the sine of 15 equals to a over 400. And that is equal to, what's 400 times sine of 15? It was, yeah, it was about 100 meters, which I'll put, yeah, so many of you got that. But make sure that you know your trig functions, okay? You need to know your trig functions. In the next chapter, and the next chapter, and the next chapter, and all the way through trig functions. It's not that much. It's just SOHCAHTOA and the Pythagorean theorem. But you got to know it, and you got to know it cold. You can't really think too much about it as you go through, okay? Okay, let's imagine this expression. I love questions like this, where I give you an expression or you have an expression and I ask, if you change this variable, what happens to the other variables? So which of the, I have y equals x squared, which of these statements is true? Statements is always true, or most consistent. All right, I'm going to stop at 115, 115. Just guess if you don't know, or ask your neighbor. They put 115. All right, all over the board here. Let's see. If y doubles, then x quadruples. That's not true. If I double y, that means that x will increase by a factor of what? Not 4, but not 16. Okay, let's say that I have this expression. Students have trouble with this. I understand. Let's say that x is in parentheses. If I put a 2 over here, what must I put in front of the x in order to make this the same equation? Not 2? Not 1/2? No, not 1. No, not 1/4. What squared is 2? Square root of 2. So I have to put a square root of 2 here in order to make this the same. All right, so this isn't true. If y doubles, then x is going to decrease actually, or increase only by root 2. So that's not true. Y is greater than x. That's the most popular answer, which seems to be true. Because you know, y is equal to x squared. So, like if x is 2, y is what? 4. If x is 4, y is, if x is a half, y is, what is, if x is a half, y is, if x is a half squared, that's equal to 1 over what? 4. What's bigger, a half or a fourth? A half. So y doesn't have to be bigger than x. In fact, if x is less than 1, y is going to be smaller than x. So that's not right. Um, C is not right either. That is a, not many of you gave C. That is a linear relationship that says if one value increases by some factor, the other value increases by the same amount. We'll see a lot of linear relationships, and you'll see that in lab too quite a bit. But the right answer is here. If x doubles, if I double this value, I get a quadrupling over here. Right? If I double x because it's squared, then I get a factor of 4 over here. Okay? You're going to see lots of questions like that, and I understand that it's sort of foreign right now. You might not have seen that in many of your classes But in physics especially, we like to think a lot about how variables change in response to other variables in a physical system. So you'll see a lot of questions like that as we go throughout all semester. All right, which of these is consistent with a value for time to the -1? Which of these have constant, or excuse me, you know, units that are consistent with 1 over time? So put in your units for each of these. V is velocity, that's meters per second, remember? X is distance or position, that's meters. And T is time, that's seconds. We need to go through each one, putting in the units for each variable, simplifying it, and find the one that is consistent with 1 over time, or time to the -1. Doing pretty well so far. I'm going to stop in about 10 seconds at 140. Stop at 140. 140. Okay, awesome. A is right. I'm just going to do that one. I'll let you on your own do the others if you like. But A is V over X. That's meters per second over meters. But I can rewrite this as meters per second times 1 over meters. That always helps me to think about it in that way. So my meters cancel, and I'm left with 1 over seconds, which is time to the -1. Um, yeah, y'all did pretty well on that. That's good. Which of these is consistent with acceleration? Remember, acceleration is meters per second squared. V is meters per second. This is meters. This is seconds. Acceleration is meters per second squared. It appears to be a little more difficult. Y'all are sort of all over the board right now. Nobody's really honing in on a right answer just yet. But you might have the right answer. Ask your neighbor. We're going to stop in 10 seconds, 135. We'll go to 140, 140. 140, stopping at 140. Okay, good. B is right. Uh, let's do a couple of these. Like let's do, for example, C. C is not the right answer, but let's do C. It's meters per second over seconds, but the V was squared, so this whole thing is going to be squared. This is C. It's not the right answer. I'm just showing you that. So this is going to be meters squared per second squared times 1 over seconds. So that's going to be meters squared per seconds cubed is C. So that's not correct. Let's look at D. it's meters per second squared over meters. So that's going to equal meters squared per second squared times 1 over meters. That cancels, leaves me with meters per second squared, which is acceleration. Probably going to have a free response problem on your test. So it'll be worth 5 to 10 points on your test, where I just give you some equation and I ask you to find the units or tell me is that equation dimensionally correct. Hopefully that'll be a gimme problem, but obviously, I mean, we still need a little work. And you can get that in your homework as you practice. Look at the old exams, practice with that. Come see me if you need. See the tutor and the tutors and the tutoring center. Any one of those avenues, if you're not getting this, I can help you with that. Okay? Because I know that some of you are not getting it right now, and that's okay to not get it right now, but it's not okay on the exam. You don't want that to be the case. This is a safe place. You feel safe? You can get things wrong here, and that's okay. But on the test, I don't want you to get it wrong there. Okay, which point is nearest the y-axis? Coordinate systems. Which of these xy coordinate pairs is nearest the y-axis? Think about your Cartesian coordinate system. What defines it being close to the y-axis? About 10 more seconds. Stopping at 35, 38, we'll say. 38. Okay, D is right. Remember, if you're right on the y-axis, what is x? 0. And as x gets bigger, that means you're getting away from the y-axis. So just remember how our Cartesian coordinate system works. We have xy coordinate pairs. Later we'll add in a z component. Okay, sig figs. Probably see this in the multiple choice part. That means you'll have 1 or 2 problems. Each will be worth about 2 to 3 points each on the test. Have this 10.5, 8.8, 3.14. If I multiply that out, I get this value. But which of these is the appropriate representation of this with proper significant figures? 10.5, 8.8, 3.14. Which is the proper way to write that answer? Now we're doing awesome. Except one person that's off kilter right now. A few people. All right, we'll stop at 45. Okay, awesome. A is right. Remember, when you're multiplying, you keep the lowest number of sig figs. When you're adding or subtracting, you keep the lowest number of decimal places. So here, 8.8 has 2 sig figs, and so you keep 2 sig figs in the answer, so that's A. I used to live on this street, O Street. You know what the worst part about that was? I had to walk a whole block to pee. I didn't really live on O Street. That's a joke. Okay. Speed of vote given in knots. Uh, if the speed of knots were to express in SI units, then the units would be what? All right, we'll stop at 32. 32. Oh, for goodness sake. Okay, yeah, that's right. Meters per second. A knot is a nautical mile per hour, meters per second. Do you get a joke for that? That was easy. Do you get a joke for it? All right. Do you know why you can never starve in the desert? Because of all the sandwiches there. All right, which of these equations is not dimensionally correct? Which of these is not dimensionally correct? When you get good with this, you can just do it in your head, but you might want to write it out now. Stopping at 1:30, 10 more seconds. I'll go to 1:35. Okay, good. C is right. Let's just pick out one. Let's see. I'm going to do this one right here. D is not the right answer, but let's just show you why it's not. As second squared equals x is meters, a is meters per second squared. I can rewrite this part as meters times second squared over meters. So those cancel. So that one is dimensionally correct, so it's not the right answer. Let's look at this one, which is the right answer. I have meters per second equals meters per second squared, that's my A, times 1 over seconds. That's my T. It's in the denominator, so it looks like that. Meters per second on one side, meters per second cubed on the opposite side. And then this is the last one, I think. Adding these digits, if you add them up, you get 57.573. What is the proper way to write the answer? We'll stop with this. Uh, I'll stop at 33, 33. Okay, D is the right answer. Keep the lowest number of decimal places. Lowest number of decimal places. Listen, we just have one more thing in chapter 1. We're going to go short briefly over integrals and graphs of functions, but that will carry us well into the next chapter where we're going to use that quite a bit. So we'll start chapter 2 on Monday, and you should be able to go and finish the chapter 1 homework in the meantime. You all have a great weekend.